Have you ever wondered how search engines like Google or Bing sift through billions of web pages to bring you the most relevant results in just a blink of an eye? How do they decide which pages are most important to your search query? One of the key techniques they use is something called TF-IDF. That's short for Term Frequency Inverse Document Frequency. It might sound complicated, but don't worry. In this video, we'll break down what TF-IDF is, how it works, and why it's so crucial in helping you find exactly what you are looking for. Imagine walking into a gigantic library with millions of books but no catalog system. Finding the information you need would be nearly impossible. Similarly, the internet is like an enormous, ever-growing library. Search engines need efficient ways to determine which documents are most relevant to your search terms. That's where TF-IDF comes into play. It helps identify which words in a document are important and relevant to a user's query. Let's start with the first part, term frequency or TF. Term frequency measures how often a word, known as a term, appears in a document. The basic idea is straightforward. The more frequently a word appears in a document, the more important it might be. For example, let's say we have a short article about gardening tips. If the word soil appears 10 times in a document that contains 100 words, the term frequency of soil is 10 divided by 100, which equals 0.1. This means soil makes up 10% of the document, indicating it's a significant term in that article. But there's a catch. Some words are very common across many documents, like the, is, and, or even domain-specific words in certain fields. If we only considered term frequency, common words might be deemed important in every document. This is where inverse document frequency, or IDF, comes in. IDF measures how unique or rare a word is across a collection of documents. The less frequently a word appears across documents, the higher its IDF score. For instance, suppose we have 1000 documents. If the word soil appears in 100 of them, its IDF is calculated as the logarithm of the total number of documents divided by the number of documents containing soil. So, IDF is equal to log 1000/100 is equal to log 10 is equal to 1. This score tells us that soil is a moderately common term across the document set. Now, let's bring TF and IDF together. By multiplying TF and IDF, we balance the term's frequency in a specific document with how unique it is across all documents. The TF-IDF score increases proportionally with the number of times a word appears in the document but decreases with the frequency of the word in the corpus. In simpler terms, TF-IDF helps us find words that are important in one document but not necessarily common across all documents. So, the TF-IDF formula is TF-IDF is equal to TF times IDF. Continuing our example, if the term frequency of soil in our document is 0.1 and its IDF is 1, then its TF-IDF score is 0.1 times 1 is equal to 0.1. So, why is TF-IDF so important? Well, it's a foundational tool in information retrieval and text mining. Search engines use TF-IDF to weigh the relevance of documents to your search queries. By calculating TF-IDF scores for all terms in a document, search engines can rank documents based on how well they match your search terms, prioritizing those with higher scores. Beyond search engines, TF-IDF is used in recommendation systems, document clustering, and even in filtering spam emails. It's a simple yet powerful way to quantify the importance of words in large sets of text. In summary, TF-IDF is a cornerstone technique that helps us measure how important a word is within a document and across a collection of documents. It strikes a balance between term frequency and uniqueness, enabling search engines and other text analysis tools to deliver relevant and efficient results. Next time you search for something online and get exactly what you need, you'll know that TF-IDF played a part in making that happen.